Here we are given this equation T of T, where T of T represents the temperature of the coffee T minutes after it has been poured. So it is given as 31.1 plus 40 e power minus kT. So this is in degrees centigrade. And we have to answer these two questions. That is, in part A, we have to determine the constant K when the temperature of coffee is 51.7 degrees centigrade after 10 minutes. And in part B, we have to find the temperature of coffee 20 minutes later to this temperature. So let's answer these two parts. The first part, we have to determine the value of K. So here it is given that after 10 minutes, the temperature cools down to 51.7 degrees centigrade, which means the T of T is given as 51.7 degrees centigrade, and the time is given as 10 minutes. So we can just put it as 10. We now use these values to plug it into this equation. So let me do that. So when I do that, I get 51.7. I replace T of T with 51.7. This is equal to 31.1 plus 40 times of e raised to the power of minus k, which is what we have to find, and then multiplied with t, that is times 10. So let's simplify this equation. I subtract 31.1 from both sides, and when I do that, I'll be getting 20.6 on the left hand side, and on the right side I get 40 e raised to the power of minus 10k. So now we have to solve for k. So this is an exponential equation. So first we will divide both sides by 40, which we can further simplify. So we do like this. That is 20.6 divided by 40 equals 40 e raised to the power of minus 10k divided by 40. So this 40 and 40 will get cancelled, and this 20.6 divided by 40, this is equal to 0.515, and this side we have e raised to the power of minus 10k. So now to solve for k, we apply natural logarithm to both sides. So when we do that, we will get a natural logarithm of 0.515 on the left side, and on the right side we get a natural logarithm of e raised to the power of minus 10k. Now I can use the property of logarithm such that this e raised to the power of minus 10k, the power will come in front, and therefore this will become minus 10k multiplied with natural logarithm of e. The value of natural logarithm of e is equal to 1. So this we can just remove this, simply minus 10k. So we have this equation, natural logarithm of 0.515 on the left side equals minus 10k. So we just have to divide both sides by minus 10 so that we get the value of k. I put this as k equal to natural logarithm of 0.515 divided by minus 10. And when you plug this into the calculator, we get approximately as 0.0663588, and it just goes on. So we just keep this number as it is. In fact, we can store this in computer, the calculator's memory. We will not have to approximate this. So this is the value of k. We now answer the question in part B. That is, we have to find the temperature of the coffee 20 minutes later. So which means we have to use the same equation. That is B equals, this is the temperature equation, 31.1 plus 40 times e raised to the power of minus kT. So let me copy the equation. T of T equals 31.1 plus 40 times e raised to the power of minus kT. Now this time I can replace the value of k which we have found it in part B, that is 0.0663588 times T. So in part B, we have to find the temperature of coffee after 20 minutes, which means we have to plug in T equals 20. So therefore this becomes T of 20 equals 31.1 plus 40 e raised to the power of minus of 0.0663588 times of 20. So we can simplify this. First, we have to multiply these two quantities, store in computer the calculator's memory, and then you have to exponentiate using the e function in the calculator and multiply with 40. So you get result, add 31.1 to that result, and when we do that, we get the result as 41.709. So this is approximately 41.7 degrees centigrade. So this is the temperature of the coffee after 20 minutes. So we have answered the two parts. We determine the value of K in part A and determine the temperature of the coffee after 20 minutes in part B.